This video is about evaluating a function in function notation and identifying independent and dependent variables. So before we can evaluate functions, we need to understand what a function is. So a function is a relationship between two quantities in which one quantity is associated with a unique value of the other quantity. So down below we have two vending machines. We have refreshments and we have cold drinks. Now on refreshments, each button is represented by one drink. So if we press A, we would get orange juice, B, apple juice, C and D, skim milk, E, chocolate milk, F, water. Now it's okay that C and D both are going to skim milk because sometimes we can have an input that will give us the same output. In cold drinks, we have A is orange juice, B is apple juice or skim milk, C is skim milk, D is chocolate milk, and E and F are water. So remember, with a function, we need to have a unique value for each input. So in this case, our machine that's going to represent a function would be refreshments, because each button, which is our input, is going to a unique drink, which is our output. So we know when I'm touching the button and I push button A, what drink I'm getting. If I push button B, I know what drink I am getting. So it's going to be a function, which means that cold drinks is not a function because button B has two output drinks. So in a math function, in an equation, we're going to have each input, or x, is going to have exactly one output, which is sometimes our y value. This is similar to a vending machine because each button gives you one drink choice. So let's evaluate the following functions. Now, what's going to happen is there's going to be a letter and then a parenthesis with a number inside it. The letter is going to tell you which equation to use, and the number is what we are going to sub in for x. So in number 3, we have f of 10, so we would take 10 and we're going to put it in for x in our f equation. So the f equation is 3x squared plus 5. We are going to put 10 in place of x. So when we do that, we get 3 times 10 squared plus 5. Then we use order of operations to evaluate. So 10 squared is 100, so we have 3 times 100 plus 5. 3 times 100 is 300, plus 5 would get us 305. In the second one, we have g of negative 22. So we're going to use the g equation. We're going to put negative 22 in for x. So our equation is x minus 11, and we're going to substitute negative 22 in for x. Remember when you substitute to put parentheses around your value. So we have negative 22 minus 11, which would get us negative 33. In our fifth one, we have h of negative 4. So we're going to take negative 4 and put for x in the h equation. So the h equation is negative 5x minus 3. We're going to substitute negative 4 in for x. So we would have negative 5 times negative 4 minus 3. Then we use our order of operations. So negative 5 times negative 4 is 20, minus 3 would get us 17. In number 6, f of negative 5, so we're going to put that in for x in our equation, 3x squared plus 5. Now it's very important we put parentheses around this because when I square it, negative 5 squared should get us a positive 25. So we have 3 times 25 plus 5. 3 times 25 is 75, plus 5 would get us 80. In number 7, we're going to substitute 0 in for x in the h equation. So we have negative 5 times 0 minus 3 would get us 0 minus 3, so negative 3. In our last one, we have g of 9, so we're going to put 9 in for x. So we would have 9 minus 11, which is negative 2. Now, variables. You've talked about variables before in science. So there are two types of variables, independent and dependent variable. The independent variable is a variable that does not change based on other variables. An example of an independent variable might be time, so hours, minutes, days, etc. You can think about your independent variable as the input into an equation. Your dependent variable then is a variable that changes based on another variable. So sometimes those examples are money and distance. This is thought about as the output. So we're going to write a dependency statement and identify the independent and dependent variables. When we write a dependency statement, we're going to have the dependent variable depends on the independent variable. So let's build up to this. So first we're going to look at just the function rule. So in the function rule, we have y equals 3x minus 9. So the independent variable, think about it as the input. That would be our x that we put into the equation. And then y is our dependent variable. It's what we get out of the equation. Number 10 is written as a dependency statement because we have the word depends on. So the number of calories you burn depends on how much time you are working out. So in this case, remember, it's dependent variable depends on independent variable. Okay, we also see that this involves time, and time is always an independent variable. So our independent variable is the time you work out. And the dependent variable is the number of calories you burn. So let's put it all together now. We're going to identify our independent and dependent variable and write a sentence. So in number 11, the time driving versus the distance traveled. Remember that time is always independent because we can't do anything to change time. So our independent variable is time driving, and our dependent variable is going to be distance traveled. Because remember, think about a situation where you are driving in a car, and the longer you drive, the more distance you covered. So our dependent statement would be distance traveled depends on time driving. Number 12, the number of songs you buy on iTunes versus your iTunes bill. So the first thing that happens, because we can also think about cause and effect, is you're going to buy the songs on iTunes. So we have the number of songs you buy. That's going to be our independent variable. And then based on that, our iTunes bill is going to be generated. So that's going to be the dependent variable. So we would have the iTunes bill depends on the number of songs you buy. And the last one, we have the cost of pizza versus the number of toppings ordered. So first you order your pizza, you tell them how many toppings you want. So that is the independent variable, is the number of toppings ordered. And then they're going to tell you the cost of the pizza, which is the dependent variable. So our dependency statement would be that cost of pizza depends on the number of toppings ordered. So let's take what we've talked about today and let's look at a situation that we'll look at for the next couple of days. So we have two flower companies that are selling roses. We have Roses Are Red and Flower Power. Roses Are Red sells roses for a service charge of $20 plus 75 cents per rose. Flower Power sells roses for a service charge of $60 plus 50 cents per rose. Now that we've explored the offers, let's see if we can figure out our puzzle here. So the blank of roses depends on the blank of roses in the order. So remember that we're going to have cost as a dependent variable. So the cost of roses depends on the number of roses that you order. Each number of roses is going to give us a unique cost because each different number of roses gives a different cost. In other words, the cost of roses is a function of the number of roses. So that's just another way of writing a dependency statement, which then makes our independent variable is going to be the number of roses, and our dependent variable is going to be the cost of roses. So using this, we can fill out a table to figure out how much roses are going to cost depending on what we order. So for roses are red, we know that it is a $20 service charge plus 75 cents times the number of roses. Now we can put all of that in our calculator at once. So we would have 20 plus 0.75 times 10, which would give us a cost of $27.50. For 50 roses, it would have a $20 fee plus 75 cents times 50 roses. So we have 20 plus 0.75 times 50, which would get us $57.50. Then we have a $20 service charge plus 75 cents times 100 roses. That would get us $95. And then we have $20 service charge plus 75 cents per 500 roses. And that would get us $395. Now, if we look at the other company of Flower Power is going to charge a service charge of $60.50 per rose. So if we're getting 10 roses, it's $60 plus 0.50 times 10. That would get us $65. If we do 60 roses plus 50 cents times 50 roses, that would get us $85. And then we have 60 plus 0.50 times 100. That's going to be $110. And then we have 60 plus 0.50 times 500. And that would get us $310. So let's look at two situations. Which store would you choose if you were buying 10 flowers? So if we were buying 10 flowers, and we look back at our table, roses are red, cost $27.50. Flower Power costs $65. So if we were trying to figure out which one is the better place to buy from, we would pick Roses Are Red because it is cheaper. And we want to know by how much it's cheaper. So we're going to take the higher cost and subtract the cheaper cost. So it is cheaper by $37.50. Now, if we were buying 500 roses from our table, Roses Are Red cost $395, and Flower Power would only cost $310. So in this case, we would want to buy from Flower Power because it is cheaper. And if I subtract $395 minus $310, this is cheaper by $85.